Hey guys, this is video 8.5. We're going to talk about limiting reagents or reactants today. Let's jump right in. This is where the page numbers on mine might be a little bit different than yours, but look for where it says 8.5, the limiting reagent, or in parentheses, reactant. Okay, so just first off, reagent and reactant mean the same thing. Don't get confused with those. You need to know basically the definition of them and then how we calculate it. The limiting reagent is what will determine how much of a product is formed, okay? So it controls the amount of product formed because it gets completely used up or consumed in the reaction. So the way that you should remember this is that it runs out first, okay? So for example, people on a plane. Let's say you have 300 people trying to board a plane. The plane has 250 seats. Which is going to run out first? Pretty easy. That would be the number of seats. That would be our limiting reactant or limiting reagent because they're going to run out before the people are all in the seats. Okay, so that's essentially what we're looking at here with a limiting reagent or limiting reactant problem. Once one of the reactants is used up and there's no more of it, the reaction will stop. Okay, so the limiting one, like I said, runs out first. We do have this piece called the excess reagent / reactant, and that's what would be left over, okay? So that one is not used up. Now in this class we're not going to worry about how to calculate excess reactant. They don't do that anymore with the reagents. Limiting would be the only thing that you need to worry about. So how we solve a limiting reagent problem is we're going to do mass to mass or gram to gram calculations for all reactants. So if you think about it, that's your long roadmap, right, where it's all 4 steps, where you start with your grams of given, and you're trying to get to grams of wanted. And again, you don't have to write this part down. This is just kind of showing you and guiding you, what you would do with that. Whichever reactant produces the least amount, that's the key, that's your limiting reagent. So this is nothing really brand new in terms of what we've learned this unit. It's just knowing what limiting reagent means and then how you identify it. But to do the work, it's the same as the last video where we do mass to mass problems. So you're going to be given the amounts of 2 reactants. You have to figure out how much is produced. So let's take a look here at this example. So it says if 5 grams of hydrogen reacts with 5 grams of oxygen to make water, which reactant is the LR, which is limiting reactant, and then how much water is produced. These two questions, guys, go hand in hand. So once you figure out the limiting reagent, you're going to know how much water is produced. What do you need before you even start this problem? You need a balanced equation. You have to always have a reaction. So if they don't give it to you, you've got to come up and write it. So we know that we have hydrogen, all right, plus oxygen make water. Now let me ask you that. Did I write that equation correctly? I've seen a lot of you guys write like this. The answer is no. Why? Why is that incorrect? You've got to remember that hydrogen and oxygen, when they're by themselves, they're part of Brinkelhoff. They're diatomic. I'm seeing a lot of people as I walk around just write down hydrogen, just write down oxygen, no 2's there, because that's going to affect your mass, it's going to affect your moles, it's going to affect everything. So now if we balance this equation, you should have a 2 there and a 2 there. So there's our balanced equation that we're going to use. So now, to figure it out, notice with this one, we only have one product, okay? So we're going to just take our starting materials, hydrogen and oxygen, and we're going to convert to that one product. Let's say, for example, don't write this down, but let's say we had some other product like oxygen gas as well, okay? If you have more than one product, the big thing you've got to remember is that you're going to take your starting materials and just convert them to the same product in the end. Because if you go to 2 different ones, you can't compare which one ran out first, which one produced the least amount. They've got to be the same product, okay? And you'll see that in this example down here where you have 2 products. You pick one. Really what you're going to want to do is pick AgCl because that's the one you're looking for anyway, but that would be the one that you would convert to. Just make sure you go to the same product, okay? But I'm going to erase this because you don't need to worry about that since we only have one product here. That's the one we're going to go to. So let's go through this. If you guys want to, what I would encourage you to do is pause it, do the 2 gram to gram problems on your own, and then check your work. But here we go. We have 5 grams of hydrogen and we have 5 grams of oxygen. We're trying to figure out how many grams of water each of those is going to produce. So I'm just setting up my problems just to kind of get my mind right. and then I'm going to start going through that. So here's my T-chart. I'm going gram to gram. I know it's going to be the long way, so I'm going to have essentially 4 fractions. Grams of hydrogen are going to go on the bottom here. Moles of hydrogen will go on the top. Notice again, I'm getting all my units set up before I plug in any numbers. I encourage you guys to do that, but I know by now you probably have your own method that you're working with since you've already taken the quiz at this point. If you haven't taken the mixed stoichiometry quiz, pause the video, take that, because this stuff, this limiting reactant stuff, is not on that quiz. I don't want you to confuse yourself with it. This stuff you could see on your summary quiz. All right, carrying on. So grams of hydrogen are gone. Now I'm at moles. I got to go from moles of hydrogen to moles of water. Okay, there's that's gone. And then I want to go from moles of water to grams of water. Okay, so whenever it says how much, guys, always assume that's grams. Okay, how much is produced, it's grams, because again, we don't measure moles directly in the lab. We can measure grams. Okay, we measure mass. So now I need to go through and plug in all my numbers. Well, anywhere I see moles and grams, mole always gets the number 1. Grams of hydrogen, that's the molar mass. This is where if you don't have those diatomics, you would have the incorrect molar mass, guys. It's 2.016. You double it because it's diatomic. The mole ratios, okay, the mole ratio here of water to hydrogen, I'm looking at my coefficients. Well, I've got a 2 for water and I've got a 2 for hydrogen. You don't have to reduce that like I am, but I'm going to, because 2 divided by 2 is just 1. Makes my math a little bit easier. And then lastly, my molar mass of water, so 2 hydrogens plus 1 oxygen, that's going to be about 18.02 grams is what you'd have for the molar mass. So then all I have to do is do my math. Okay, I would get 44.68-ish, but I'm going to round that to correct sig figs, so it would end up with 45 grams of water. So that's half the problem. Now I've got to go through and do the same thing with my other reactant, because again, I want to find out which one runs out first. So I've got to go gram to gram with both reactants from what I start with and see how much they produce. Whichever one produces the least amount of water in the end, that's the one that is my limiting reactant because it ran out first. Okay, so same thing. The first part of my T-chart is going to be exactly the same. Oh, nope, I'm sorry. The last part here, oh boy, you guys are going to be mad at that. My bad. Always look at your units. Don't just assume like I just did. Good teaching moment. So grams of oxygen are gone. Moles of O2 here. Now the end part is going to be the same because I'm going to water, even though my reactant is different. My starting place is different. Okay, so 1 mole of oxygen, 1 mole of H2O. We said that H2O's mass was 18.02. If we look for the mole ratio, I've got a 2 for water, I've got a 1 for oxygen, can't reduce this time. And then oxygen's mass is going to be 32 grams because, again, it's 2 times essentially 16. So I can reduce if I want to, or I can just plug all my numbers in. Either way, you should end up, rounding correct sig figs, about 5.6 grams of water. Okay, so when you take a look at these two values, based on how much water we had to start with, if oxygen was in excess, if we had an unlimited supply of oxygen, we could produce up to 45 grams of water based on starting with 5 grams of hydrogen. Okay, so based on starting with this amount, we can produce, up to 45 grams if all of it reacts. Now, with oxygen, okay, if we start with 5 grams of oxygen and let's say we had unlimited supply of hydrogen, we could produce at most 5.6 grams of water because the oxygen would be used up. So here, when we look at both of these, oxygen is going to be our limiting reactant because it runs out first. By looking at how much product could be formed, okay, the limiting reactant produces the least amount. So in this case, 5.6, that means that oxygen is our limiting reactant because it runs out first. So we just answered both questions, okay? We answered which is the limiting reactant, that's oxygen because it runs out first, and then how much water is produced, well, that would be how much your limiting reactant produces, would be how much you can actually produce, okay? So it's very similar to what we've already done. The lights just turned off. Oh, well, you don't need to see me. So it's the same as what we did in the last video, gram to gram. It's just applying that definition, okay? So what I want you guys to do is pause the video, try this problem on your own. If you get stuck, hit play, and kind of see where you get stuck at. All right, so I'm going to work through this problem, and then you guys can check your work. So I have 15 grams of salt, so NaCl, reacts with silver nitrate, AgNO3. It's going to produce silver chloride, AgCl, plus sodium nitrate. And how I got all those guys, I used my crisscross method. Notice this is already balanced, so that's going to make my work a little bit easier. We're going to figure out the limiting reagent and how much AgCl is formed. So since we have two products here, we want to make sure that whatever we go to compare them, that we go to the same product. Now the product that I'm going to choose here is AgCl, since we have to figure out how much of that's formed anyway. You could convert both of them to NaNO3, guys, sodium nitrate, but then you would also have to go back and redo a third gram to gram problem using your limiting reactant to get to AgCl. So make your work a little bit easier, a little bit quicker. Just go to AgCl right from the get-go. So I've got 15 grams of NaCl, and I've got 20 grams of AgNO3. All right, so gram to gram, I'm trying to get to grams of AgCl. All right, I'm going to kind of go through this quickly. So my next fraction here, I would have 1 mole of NaCl over 58.44 grams of NaCl. Those cancel out. My mole ratio is going to be pretty simple. 1 mole of AgCl over 1 mole of NaCl. Those cancel out. And then my last one is going to be just the molar mass of AgCl, which for me, I calculated it to be about 143.32 over the 1 mole of AgCl. Units cancel out. When I get my final answer, I get about 36.8 grams of silver chloride. Now down here, all right, 1 mole of AgNO3 is about 169.87 grams of AgNO3. That cancels out. My mole ratio is 1 to 1. Those cancel out. And then my last one, same molar mass because it's the same substance that I went to in the previous one. Cancel out. And then my final answer when I do the math is about 16.9 grams. So when I take a look here, which one is my limiting reactant? Limiting reactant is going to be AgNO3 because it produced the least amount of my product. So 16.9 grams of AgCl, that's my answer for part B. And then my limiting reactant is going to equal AgNO3. So remember, guys, with limiting reactant, you've got to go back and tell me what the reactant was because it's limiting reactant, not limiting product. Okay, it's the reactant. If you have questions, call me over. All right, but make sure you know your definition, and I will see you guys in the next video.